Welcome to today's video, where we'll discuss support vector machines and their application in data mining. This presentation is designed for senior undergraduate students interested in understanding how SVMs work and how they're implemented. Let's start with an overview of what we'll cover. First, we'll define support vector machines and explain what hyperplanes are. Next, we'll discuss how SVMs classify data by maximizing margins. We'll explore different kernel functions that help SVMs handle non-linear relationships. Finally, we'll look at implementing SVMs for classification using Python's scikit-learn library. By the end of this video, you'll have a solid understanding of these foundational concepts. Support vector machines, or SVMs, are supervised learning algorithms that use hyperplanes to divide data into distinct classes. A hyperplane is essentially a flat surface, one dimension lower than the input space. For example, in a two-dimensional feature space, a hyperplane is a line, and in 3 dimensions, it's a plane. SVMs use these hyperplanes to create boundaries between different classes in the data. When classifying data, SVMs identify the hyperplane that best separates classes. They maximize the margin, which is the space between the hyperplane and the nearest data points from each class. These closest points are called support vectors, and they play a crucial role in defining the hyperplane. Kernel functions are an essential part of SVMs because they allow the model to handle non-linear relationships by mapping data into higher dimensional spaces. Common kernel functions include the linear kernel, which uses the original features directly, the polynomial kernel, which maps inputs to polynomial feature spaces, and the radial basis function or RBF kernel, which maps inputs based on distances from data points. Finally, we'll briefly describe how to implement an SVM in Python using scikit-learn. The process involves preparing the data, scaling it with a standard scaler, and fitting an SVM model using the desired kernel. Once trained, the model can predict outcomes on test data, providing a practical tool for classification tasks. To summarize, SVMs use hyperplanes to separate data into classes, relying on support vectors and margins for optimal classification. Kernels allow SVMs to handle non-linear data effectively, and scikit-learn makes implementation straightforward for practical applications. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.